Okay, let's give you guys some practice. So use change of variables to evaluate this double integral. So press pause and have a go. Okay, so to do this, we have no idea what this is talking about, what region this is talking about. So let's try and sketch it. Let's rearrange this to make y the subject. So times 2, so y equals 2x. So you know that this has a gradient of 2. And then rearrange this. This would be x minus 1 times 2 equals y. So that will have an intercept of -2. So it will look something like this. And then this thing here, y equals 0 is here, and y equals 4 is here. So what this is talking about is this region here. So if you try and understand what's going on in the x direction, so that's you moving in the x direction like this, parallel to the x-axis, you're actually starting at this line, which is this, and then you stop at the other line, which is this line here. And then you're scanning from 0, you're scanning from y equals 0 to y equals 4. So this is our region here. So far we know this. So far we know this. We know that this is our region. And now the hard part. The hard part is in making the change of variables. You want to transform. Well, when you think about the change of variables, think about the integrand and think about your region. You want to let u equal something, v equals something, in such a way that your integrand becomes simpler or your region becomes simpler. Well, if you look at this, this doesn't look very complicated, so let's ignore this. Looking at the region, you want to morph this into a constant. So you want to morph this into a constant. So you want some sort of like you want u to be some sort of constant. So you want to morph this line into some sort of constant here, and then this line into some sort of constant here. Let's start again. If you take away 2x from both sides, so that would be y minus 2x equals 0, and then take away 2x from both sides, so y take away 2x equals -2. See this? This is a constant. This is a constant. So let u equals this thing. Let u equals this thing here. So to make our change of variables, let u equals y take away 2x, and then by making this this substitution, this will become u. So u equals -2. Look, this is a constant, and then this thing here will become u equals 0. See, this is a constant. So what this is saying is that u equals 0 would look like this, somewhere along here, u equals 0, and then u equals -2. -2. Let's just say this is -2 here, -2. And then this is quite simple. This is quite simple. So let's say let v equals y. Let v equals y. So this would be v equals 0, v equals 4. So this would be v equals 0 is here, v equals 4 is here. So this is our region. So by making this, the change of variables here and here, this thing here will then morph into this. Okay, so our next task is to let u equals this and let v equals this. So we are currently here. We are currently here. So when you make the when you make the change of variables here, this region will become this region here. But then if you make the substitution here, then you need to make some sort of adjustment, and this is your Jacobian. We need to compute the Jacobian later on. But then let's look at the region. dv, so you're moving parallel to the v-axis, so you're actually starting at 0, you stop at 4. You start at 0, you stop at 4. So that means you start at 0, you stop at 4. And then in terms of the u, you're scanning from -2 all the way to 0. You're scanning from -2 all the way to 0. And now we need to work out our Jacobian. So we are and this is a constant. So we can drag the constant -1/2 out here. So that would then become this. That would then become, remember that this thing here would just become u, and then when you drag the -1/2 out, that would then be this. So we are now currently here. We still need to work out our Jacobian. Okay, so hang on. So we still need to work out our Jacobian. When you get to this stage here, you can either choose to work all in terms of u and v, so we can work out our Jacobian here, or you can work all in terms of x and y. Remember, this was our substitution. We weren't given this, but from this you can eliminate y, so you can put this into here. So that would then become u equals v minus 2x, and make x a subject. So v minus, well, whatever, make x a subject. That will then give you this, and y. But the point here is that when you make the change of variables here, you can always work this out. Well, when you're here, you have a choice: either go in this direction or take this route. Both methods would take you to the same answer. So if you decided to work all in terms of x and y, you compute your Jacobian, and then your adjustment would be the absolute value of the Jacobian, u, v. But if you decide to work in terms of u and v, then your adjustment will be 1 over the absolute of the Jacobian. So it doesn't matter which way. This time I'm going to take this route. Okay, so let's work all in terms of x and y. So to compute the Jacobian, differentiate x with respect to u. So differentiate x with respect to u, that would be -1/2. And then differentiate x with respect to v, that would be 1/2. That would be 1/2. And then differentiate y with respect to u. Well, there is no u, that's why it's 0. And then differentiate y with respect to v, that would be 1. And then the determinant of this would be this times this, take away this times this. That would be -1/2. But then what goes into your adjustment would be the absolute value. So so it will be positive. Well, it would be positive 1/2. Okay, if you decided to work in terms of u and v, then the Jacobian would look like this. But remember, if you decided to work in terms of u and v, then what goes into the adjustment would be 1 over that absolute value. So it's still 1/2, just like down here. The absolute value of this is 1/2. So both methods lead to the same answer. Okay, so the adjustment that we need to make is actually 1/2. So now this is a constant. Drag it out here, so that becomes -1/4. So that becomes -1/4. So now it boils down to us trying to evaluate this double integral. So now looking at the inner integral, integrate it with respect to v. So that would be uv from 0 to 4. From 0 to 4. So now put 4 into the v. That would be 4u. And then put 0 into the v. That would be nothing. So that would then take us to here. And then this is a constant. Drag it out. That would be -1. Now it's just a matter of integrating u. So integrating u would then give you this from -2 to 0, -2 to 0. So now put this into here, that would be nothing. And then put this into here, you square it, that would be +4 divided by 2. blah 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 blah. The answer is 2. Your final answer is 2. Okay.